Let us understand special function registers of 8051 microcontroller, their addresses, and whether these registers are bit addressable or byte addressable. Now, as we know, this special function register resides from address ATH to FFH, and few registers are bit and byte addressable. That means you can read whole byte or write whole byte, or you can read or write a single bit of this register. And if register is only byte addressable, then you can read or write a whole byte only. You cannot read or write a single bit. Now the first register is accumulator. It is generally written as ACC, and it is bit as well as byte addressable. The address of accumulator is E0H. So in instructions, we can use accumulator as register A, or we can use address of this register as E0H. For bit addressable, we have to use ACC, that we'll discuss. The second register is register B, which is generally used along with accumulator for some operations like multiplication, division. So this is also called as a math register. This is also bit and byte addressable. The address of B register is F0H. Next is DPH, that is higher 8 bits of DPTR register. It is only byte addressable and its address is 83H. The address of DPL is 82H and it is also byte addressable. So here also we can use name of this registers, or we can use addresses of this register in assembly language instructions. The next is register IE, which is interrupt enable control register. It is bit as well as byte addressable and its address is A8H. The next is IP, that is interrupt priority register. It is also bit and byte addressable and its address is B8H. These two registers are used for interrupts of 8051. The next registers are related to port. Each port is having one register, like P0 port is having register P0, then P1 port P1 register, P2 port P2 register and P3 port register. The addresses are 80H for P0, 90H for P1, A0H for P2 port and P0H for P3 port. All these port registers are bit as well as byte addressable. Next register is PCON register, which is power control register. It is a byte addressable register and its address is 87H. Next is PSW register, bit and byte addressable, that is program status word register and its address is D0H. Then SCON register, that is serial port control register, bit byte addressable and address is 98H. Next is serial port data buffer register, SBUF register, byte addressable and address is 99H. Then stack pointer register, whose address is 81H and it is byte addressable. SCON and SBUF, these registers are used for serial communication. And stack pointer register by default is initialized with value 07H. Next registers are related to timer. TMOD register, it is timer counter mode control register, whose address is 89H and it is byte addressable. TCON register, bit byte addressable, timer counter control register, address is 88H. TL0, timer 0 low byte register, address is 8AH and this is byte addressable. All these registers are used to store count in timer and counter operation. TH0 is timer 0 high byte, address is 8CH, byte addressable. TL1 is byte addressable, timer 1 low byte register 8BH. TH1 is byte addressable, timer 1 high byte register, address is 8DH. How to use this bit addressable register? So accumulator 8-bit register, so it is having bits from D0 to D7 and address of accumulator is E0H. Generally ACC is used to represent individual bits of accumulator. So this is D0 bit, it can be written as ACC.0. This bit is written as ACC.1. This bit is written as ACC.2. Like that, this bit is written as ACC.7. So for bit addressable instruction, we can use individual bits of this particular register. So to access this D0 bit, we have to mention ACC.0. For example, clear instruction is generally used to clear the bit, that means to store here 0. So we can use bitwise clear instruction CLR ACC.0. So this instruction will clear only value of this particular bit, all other bits will remain as it is. So this is advantage of bit addressable instruction. We can operate on individual bit. To set this particular bit, suppose I want to store here 1 for ACC.1. So instruction use it set bit ACC.1. This instruction we'll discuss in detail in other lecture. So this is about accumulator. So only for accumulator this different name is used ACC. But we'll consider example of port P0. Along with this name we can use address of individual bit. So address of accumulator is E0H. So address of this bit is E0H for bit addressable instruction. Address of this bit is E1H. Address of this next bit is E2H. So address of this bit is E7H. So we can use addresses also, or we can use this nomenclature. So generally these names are used, no need to remember addresses. Now for example, we'll consider the second example for port P0. Address of port P0 is 80H. So it is also 8-bit register. So it will have bits D0, D1, D2 up to D7. Now to access this particular bit, we can write P0.0. Here also we can write P0.1. Here P0.2 and here P0.7. So for bitwise instruction, we can use this individual bits in the instruction. Only for accumulator, this ACC new name is used. For all other register, we can use name of register and dot position of that particular bit. So here also to clear this bit, suppose I want to clear this bit, we can use bitwise instruction clear P0.1. To set up one particular bit, we can use instruction set B P0.1. So this individual bits we can set or reset using this instruction.